We're going to look at finding the greatest common factor and least common multiple of the two numbers 36 and 45 using prime factorization. So the first thing that we need to do is we need to find the prime factorization of each number. And today we reviewed how to do that using a factor tree. So we are trying to find the longest factor string for 36. And remember, you cannot include 1 as a factor because 1 is not a prime number. So if we look at a factor pair for 36, maybe you chose 4 and 9. As we talked about today, it doesn't really matter which factor pair you choose because we'll continue to decompose these numbers until we get a factor string that includes all the prime numbers here. So our factor string here is 2 times 2 times 3 times 3 for 36. And over here for 45, I get 3 times 3 times 5. And I know I can't make that factor string any longer because these are all prime numbers. So once I have those factor strings, in order to find common factors, we need to compare the two prime factorizations. And you'll notice over here that the prime factorization of 36, it has 2 3's, and so does the prime factorization of 45. Now those 2 3's are the only factors that they have in common, which tells us that 3 is a factor, but so is 3 times 3, also a common factor. So the greatest common factor is going to be taking all of the factors that both prime factorizations have in common and then multiplying them to get a product here of 9. So 9 is the greatest common factor. Now to find the least common multiple, we take this one step further. Remember now, multiples have to include this entire factor string of 36 because a multiple by definition is taking that number 36 and then just multiplying it by some other factor. So the first thing that you want to do is use the greatest common factor, the numbers that we have in common, the ones that I had already circled. And now we need to say, okay, what else was over in this prime factorization of 36? Because in order for it to be a multiple of 36, we must include that entire factor string. So we have to add 2 factors of 2. Next, we have to look at the other prime factorization and say, what else needs to be included here? And you can see that we have not yet included the 5. So now we just need to take 2 times 2 times 3 times 3 times 5 and do the math there. And when we multiply that all out, we get 180. So the first step is finding prime factorizations of both numbers, and then looking at the factors that they have in common from that prime factorization, multiplying those together to get the greatest common factor. And then the least common multiple is that greatest common factor times the leftovers here that we haven't used yet. 2 times 2 comes down here, and the 5 comes over here to get a least common multiple of 180.